For decades, we've told ourselves a fairly neat and tidy story about the universe. It starts with a big bang, followed by the slow, majestic formation of stars, galaxies, and eventually the black holes that anchor them. But recent discoveries, especially from the unparalleled gaze of the James Webb Space Telescope, JWST, have completely shattered this orderly picture. We're now seeing things that, according to our own theories, simply didn't have time to form. We're finding giants in the cosmic nursery. So, let's quickly recap the story we thought we knew. The universe is born 13.8 billion years ago. For a few 100 million years, it's just a dark, hot soup of gas. Eventually, this gas cools and starts to clump together, forming the very first stars. These primordial stars are absolute titans, hundreds of times more massive than our own sun. They live fast, die young, and end their lives in cataclysmic explosions called supernovae. When these massive stars die, their cores collapse under their own crushing gravity, squeezing down into an infinitely dense point, a black hole. This is the standard model for how stellar mass black holes are made. These are the seeds. From here, the story goes that these baby black holes spend billions of years slowly growing. They sip on surrounding gas and dust in a process called accretion. And, like cosmic predators, they merge with other black holes, combining their mass and getting bigger and bigger. It's a slow, steady, and predictable process that should take billions of years to create the supermassive black holes we see at the heart of most big galaxies today, including our own Milky Way. These are cosmic behemoths weighing millions or even billions of times the mass of our sun. It all made perfect sense. A gradual, elegant evolution from stellar seeds to galactic monsters. At least it used to. But this is where the story completely breaks down. The James Webb Space Telescope was built to peer back into the cosmic dawn, to see the universe's first light. And it has succeeded beyond anyone's wildest dreams. In doing so, it has uncovered a profound and troubling mystery. JWST is finding supermassive black holes that are already fully formed when the universe was less than 1 billion years old. In some cases, we're seeing them at just 700 or even 470 million years after the Big Bang. These aren't just slightly oversized black holes. They're monsters, weighing in at millions to billions of times the mass of the sun. According to our established models, this is flat out impossible. The standard ways of growing, slowly sipping gas and occasionally merging, are nowhere near fast enough to build such giants in such a short amount of cosmic time. It would be like finding a fully grown redwood tree that's only a week old. It defies the known laws of growth. These early black holes are too big, too early, and they shouldn't exist. And yet, there they are, staring back at us from the edge of time. This isn't just a minor puzzle, it's a fundamental challenge to the standard model of cosmology. So how can astronomers be so sure? When we look this far back in time, we're not actually seeing the black holes. They are, by definition, black. Instead, we see the absolute chaos they create. As a supermassive black hole furiously gobbles up matter, the gas, dust, and stars swirling around it form an intensely hot, brilliant structure called an accretion disk. This disk shines with such ferocious intensity that it can outshine entire galaxies. We call these brilliant beacons quasars. By analyzing the light from these incredibly distant quasars, astronomers can figure out the properties of the black hole at their center. The brightness tells them how fast it's feeding, and the motion of the gas reveals the sheer gravitational force at play, which in turn gives them the black hole's mass. JWST's incredible sensitivity allows it to detect the faint, red-shifted light from these objects, including a whole population of mysterious things now nicknamed little red dots. Many of these dots, once thought to be young galaxies, have been unmasked as the blazing hearts of active supermassive black holes in the infant universe. The evidence is undeniable. The monsters are real, and our understanding of how they got there is deeply flawed. Faced with this impossible evidence, scientists are scrambling for an explanation. If black holes can't grow this big this fast, then maybe they were just born big. This has led to a fascinating and revolutionary new set of theories that basically toss out the old rulebook. The leading contender is a theory called direct collapse. This idea proposes that under the very specific conditions of the early universe, you could skip the whole star formation part. Imagine a colossal cloud of primordial gas, hundreds of thousands of times the mass of our sun. Today, a cloud like that would fragment and collapse into thousands of individual stars. But in the pristine environment of the early cosmos, which was free of the heavy elements that help gas cool down, This giant cloud could have stayed together. Instead of breaking apart, the entire thing collapses under its own gravity, all at once, directly forming a massive black hole seed. Instead of starting with a light seed of a few dozen solar masses, this process creates a heavy seed of 100,000 solar masses, or even more. Starting with a seed this massive completely changes the game. It gives these black holes a monumental head start, letting them reach supermassive status in the short time available. But direct collapse isn't the only idea on the table. The existence of these impossible black holes has opened the door to even more exotic physics. One theory actually involves the mysterious stuff that makes up most of the matter in the universe: dark matter. Some scientists have proposed that decaying dark matter could have provided an extra source of heat in the early universe, preventing those giant gas clouds from fragmenting and therefore enabling a direct collapse. And then there's the most speculative yet tantalizing idea of all: primordial black holes. This theory suggests that some black holes weren't formed from stars or gas clouds at all, but were actually forged in the fiery crucible of the Big Bang itself. In the first fractions of a second of the universe's existence, tiny quantum fluctuations could have created regions so incredibly dense that they collapsed directly into black holes. These wouldn't be just any black holes. They could have formed with a whole range of masses, potentially including the heavy seeds needed to explain the supermassive giants that came later. While there's still no direct evidence for primordial black holes, the mystery of their early, oversized cousins keeps this mind-bending theory very much in play. These aren't just competing theories. They represent a fundamental fork in the road for our understanding of the cosmos. Does the answer lie in a new, more dramatic model of formation like direct collapse? Or does it require us to invoke something truly exotic, like primordial black holes or new properties of dark matter? What do you think is the most plausible explanation? Let me know your thoughts down in the comments. The discovery of these impossible black holes is more than just an astronomical puzzle. It's a huge moment in science. It's one thing to label an object as one of the largest ever found, like the quasar TON 618, which is powered by a black hole weighing a staggering 40 to 66 billion times the mass of our Sun. But it's another thing entirely to find such massive objects so early in cosmic history. It shows us that the universe's early years were far more violent, rapid, and dramatic than our neat, orderly models ever predicted. These discoveries are forcing a complete rewrite of the first chapters of the cosmic story. They challenge our models of how galaxies form, how matter evolves, and maybe even the fundamental laws of physics itself. The universe, it seems, has always been in the business of creating monsters. We are living in a golden age of cosmology, where our most powerful tools aren't just confirming what we know, but are revealing the breathtaking depth of what we don't. The history of the universe is being written as we speak, and for the first time, we have a front row seat.